Number 40. This looks really complicated. I would tell you the easiest way to do a problem with all these fractions like this would be to find a lowest common denominator. This would just be 15 over 1 between all of the denominators and multiply everything on both sides by that number. That'll cancel all the fractions out and I think make it a lot easier to work with. So 5, 10, and 20, and 1 all go into 20. So here's what I would do. I would multiply everybody on both sides by 20. This would become 20x over 5 plus 20x over 10 plus, that would just end up being 15 times 20, which is going to give you 300. And this guy over here is going to be 20x over 20. Okay, now, if you have selected something that is going to be all the numbers in the denominator go into, all these fractions should disappear. This will become 4x, this will become 2x, this is going to stay 300, and this is just going to become x. Now, if it was me, this becomes 6x plus 300 equals x. I like to try to keep my variable positive, but in this case, that's not going to happen. So I would subtract 6x from both sides. We get 300. 1x minus 6x would be negative 5x. And then I'm going to divide by negative 5. And that would be my answer. So negative 60 is what x is equal to for this question. You can plug that back in to check. Okay. Little tiny example before I start this question. So let me grab a different pen. Okay, if I have absolute value of x is equal to 5, just a real basic example, that means x is 5, or x could also be negative 5. Both of those would be solutions to that absolute value. So I'm going to keep that in mind. When you're solving an absolute value, I can drop the absolute value. I'm just going to do 3x plus 2 is equal to, think about how I did this. This was like the positive 5. So I'm going to go ahead and just keep that exactly the same. Or 3x plus 2 equals, like we did over here, the negative 5. If you have an expression, what you just do is make each of the terms the opposite. So since this was a positive 4x, that'll become negative 4x. This was a positive 5, this would become a negative 5. We're going to solve both of these equations. So here I'm going to move the 3x and I'm going to move the 5 in the same step. 2 minus 5 is going to give us negative 3, and 4 minus 3 will just give us an x. So one of our possible answers here is negative 3. Okay, here's my other answer. I'm going to add 4x, and I'm going to subtract 2 in the same step. Now this is going to be 7x, and then it equals negative 7. So our possible other answer is negative 1. Now, you have to check for extraneous solutions. If this is just equal to a number, like I have my absolute value equal to 5, you're not going to have extraneous solutions. If you have an expression, though, that can introduce possible extra answer. We did all our algebra right, but maybe the answer just doesn't work. So I'm going to do a quick check here. Okay, so if I do 3 times negative 3 plus 2, I'm going to just check to see this is equal to 4 times negative 3 plus 5. Okay, so this is going to be negative 9 plus 2, and this is going to be negative 12 plus 5. This would end up being negative 7. This would end up being negative 7. The problem is when I take the absolute value here, no bueno, that is not true. So this is actually extraneous. That's not a solution. And I know I'm bleeding into the next problem here. Let me scooch this up. I'm going to check that negative 1. So if I do 3 times negative 1 plus 2, we're just checking this. 4 times negative 1 plus 5. In here, I'm going to end up with negative 3 plus 2. This is negative 1. Over here, we're going to end up with negative 4 plus 5. Now this is 1, and when I take my absolute value here, 1 is equal to 1. So this solution, x is -1, is okay, and I did have an extraneous solution. So there's only one answer to this question, and that's the -1. Don't forget to check. Okay, I'm going to pull an x out in front here. Left over, we're going to have x squared minus x minus 42. This can be factored. Factors of -42 that add up to -1, x minus 7, and x plus 6. Now, original problem, x to the third, I should have 3 answers. Anything that would set this equal to 0. So out in front, if I plug in 0, that's going to wipe out the whole thing, because every term has an x. This would be 0 times 0 times 0. So we're done here. 0 minus 0, excuse me, minus 0. If I plugged in 7, that would cause this to be 0 if I plugged in -6. So my 3 answers here, 0, 7, and -6. Number 43 is a bunch of different questions about this box plot. So first period test scores here, second period here. If you guys remember, I'm just going to make a little mark. 25% of the data falls into each of the quartiles here. So I'm just going to make that little note on these 2 different graphs, because those questions down underneath are going to ask us some stuff about this. 25% in each quartile. Okay, half of the test scores are over what value for first period? Okay, 50% here, 50% here. Over what value is going to be the median here? And if we drop down, that should be 80. Find the median value for both classes. Okay, for first period, it's 80. For second period, it's 85. The median is the vertical line that's going to be inside the rectangle. 25% of the test scores in second period are above what value? So 25% of the test scores are here, so that looks like it's above 90. And which classes, oh, forgive me, this should be possessive. Classes. Data is more spread out. Explain how you know. This class's data is way more spread out because the range is bigger. So I would say first, their range is, looks like, let's say, maybe even like 97 down to 60, whereas the second period, their range is a lot smaller, only from 70 to 95. So the first period data is more spread out because you've got a larger range. All right, and I don't think I was on the screen. Sorry, guys. Absolute value inequality. Okay, first thing, isolate the absolute value. Divide by 3. Okay, so I'm going to come over here. X plus 6 in the absolute value is greater than 3. Okay, doesn't matter what's in here. If I'm bigger than 3, I'm numbers like 4, 5, 6, 7. So the way you break this up, if x plus 6 was greater, forgive me, greater than 3, that'd be good. Now, absolute value has kind of a special thing. So if I take the absolute value of -4, -5, -6, those would actually become values bigger than 3 when I take the absolute value. So you're going to be greater than that number or less than the opposite of this number. So I'm saying numbers like -4, -5, -6 when I do this. So this is going to be an or statement. I always remember if this is a greater, I remember great or than statement, or greater than or equal to, that would just include an extra line under your inequality symbol. Now, it's -6, -6. This would be -3, -6, -6. This is -9. Now, come over here to my lovely graph. Okay, or statements should point away from each other. So -3, 4, 5, 6, 7, 8, -9 would be here. Okay, both of these should be open circles. And we're going to point away from each other. Because I'm greater than -3 goes to the right, less than -9 goes to the left. If you start plugging in these values for x, like if I plugged in -10, I come back to this problem right here. -10 plus 6 would be -4. When we take our absolute value, though, that's bigger than 3. These values on this end are going to give you this situation where the numbers are going to be bigger than 3. So these are going to be numbers like 4, 5, 6 when you put them in here. Okay, couple ways to do number 45, totally up to you. If you want to use substitution, you could just do that real quick. Negative 9 equals x squared minus 2x minus 8. Add the 9. This is going to be x squared minus 2x plus 1. And this can actually be factored into factors of 1 that add up to negative 2. X minus 1 times x minus 1. So x minus 1 squared. Okay, so there's only one x value here. The y value is negative 9, so this would be 1, negative 9. And it says how many solutions? My answer for that question would just be 1. If you want to look at the graph, I would definitely suggest that. Oh, get that glare off of there, sorry. I'm going to go y equals, I'll just clear this out. X squared minus 2x minus 8, and just negative 9. So I'm going to go ahead and hit graph. Oh, fail. Sorry guys, I'm going to have to change the window. Oh, well, wait. Maybe be able to see it here. Let me go, I'll just make it 10. Just do a negative 10 to 10. Okay, you see this brushes by just in that point. If you want to find the intersection there, you can do second calc, intersect. Just keep hitting enter and it should hone in on that point. Now this is rounding. It should be exactly equal to 1 and negative 9. So one solution here. Just one spot they have in common. It's the vertex of that parabola. Now 46. This is basically just a vocab review. If you have these are parallel lines, that type of system is called inconsistent. Parallel lines, no solution, inconsistent is the vocabulary term for that. These are two lines graphed right on top of each other. This is the same line, ends up being in the system. This is infinite solutions, and the vocab term here is called dependent. I always think about one line depends on the other. All right, these are two intersecting lines, and you can see, don't know exactly what that point is here, but we have one solution, and the vocab term here is called independent. I always think intersecting is independent. Now the very last one at the bottom here, and then I'm going to just flip the page and do the last three real quick. Which R value indicates the strongest linear relationship? Okay, this is going to be closest, I can spell, I swear, closest to 1 or negative 1. If your R value is 1, you have a perfect positive correlation. If your R value is negative 1, you have a perfect negative correlation. So this would just be a slope that's positive for your line, and this would be a slope that's negative. So what we're looking for is the number closest to either 1 or negative 1. So this is not even close. This is 0.5. These are the two it's between. This is closer to negative 1. This is obviously closer to positive 1, but this one is closer to negative 1 than this is closer to positive 1. So this would be the strongest linear relationship. This one would be the weakest. This is pretty good, but this one's better. This just has a negative correlation and this one is positive, but it doesn't matter whether it's positive or negative. It's closest relationship to the values in your data table. So answer here would be A, weakest would be D. Let's just flip it over and finish these last three real quick. Okay, so number 48. Okay, two classes wore pedometers for 1 week and recorded the number of miles each student walked. The data for each class is recorded in the dot plots. Which data set has the lower standard deviation? Okay, here's the deal. The higher the standard deviation, the more spread out your data is from the mean. The lower your standard deviation, the closer the data is to the mean. Okay, so if we want the lower standard deviation, we want the less spread out data. the data in this class is a lot more spread out. These guys are all concentrated in the same area. So this group, you don't have to calculate it, we're just visually looking at this. This is going to have a lower standard deviation. Okay, we're going to break out our calculators for number 49. All right, hopefully no glare. Stat, edit, clear out anything you got in here. X values go in list 1, -2, 0, 2, 4. Don't type the 6. Okay, you can't have an empty box, so don't type the 6. Arrow over to list 2. -8, 0, 12, 28. Okay, make sure we don't have any that are mismatched or it won't run. Okay, now, I know you can't see my hand, so I'm going to move it up a bit. After you've input your data, stat. I'm going to pull this down a little bit so you can see a screen. Okay, calc, we want the quadratic regression. That's number 5. Now, we don't need to graph this or anything. I literally strictly just want the equation, so you don't need to store the equation. Just keep hitting enter till it shows up. Okay, quadratic regression. The a is 0.5, so it'd be y equals 0.5x squared plus bx. B is 5, so this would be 5x plus c. Now, the c, as you guys can see on my screen, is just 0. So if you want to write plus 0, go for it. You don't need to. This would be what I would be looking at as a quadratic regression. Now, once I have that, we can fill in this box. This would be the y value, 0.5 times 6 squared plus 5 times 6. This would be 36, and half of that would be 18, plus 5 times 6 is 30, so our missing value here should be 48. That's the final answer to that question. And one last question. Thomas has the following test scores so far this semester: 84, 92, 88, 89, and 95. I'm going to add these up, so I'm just writing that down as I go. What score does he need on his 6th test? Let's just use an X to represent that. To have a 93 as his average. Okay, so we know 5 tests. Here's the 6th one, so the average is going to be out of 6 total tests. Easiest way I can tell you to do this problem, let me just add those up real quick so you guys can see. 84 plus 92 plus 88 plus 89 plus 95. Hopefully I didn't type anything wrong. 448. Okay, 448 plus x, not times x. 93. Okay, now, I don't want to deal with the fraction, so let's just get rid of it. I'm going to multiply, I got that glare on the screen, darn it. Okay, we're going to multiply both sides by 6. 93 times 6. Over here, if you multiply by 6, it's literally just going to cancel out the denominator. Okay, so 93 times 6 is 558. And to get x, I'm just going to subtract the 448 and 110. So, I would say, too bad, Thomas, you can't get a 93 because the highest grade you can get on a test is 100%. So for this particular question, he's out of luck. He's not going to be able to get a 93 because he'd have to get over 100%. So unless he's getting extra credit, I would say he's not in good shape.